Welcome to a lesson on trigonometric ratios. This may be the first time you're looking at this. It is a fairly not complicated, but it is a fairly major topic. I think that's the best way to say it. It's a major topic in mathematics in some countries like America, I believe. You know how in Australia we just have maths and English and science. In some countries, they actually split up maths. And one of one of the topic in some countries is actually trigonometry. It's a whole topic. There are whole textbooks on trigonometry. So anyway, let's just get started. Trigonometric ratios and our breakdown. So we're doing exercise 8D, trigonometric ratios. Two words here, trigonometric, trigonometry, and ratios. So what's trigonometry? Trigonometry deals with the relationship between the sides and angles in a triangle. And there actually is a relationship. And to demonstrate this, I've set this up. It's a triangle. It's an isosceles triangle. It's got sides BC, right, is 5, let's say centimeters. And then AB or BA is also 5 centimeters. So that's fixed, right? What I want you to focus on is the angle in red, which says 89 degrees at the moment, and that red line, AC. Now, as I increase AC, the angle will increase. See, as AC is getting bigger, the angle is increasing. Like it's BC and AB are not changing. They're still 5 centimeters. I've locked them in. But as I decrease the length of the side, the angle is getting smaller. So every angle is related to the side opposite it. And I think that should make intuitive sense because you can think of AB and BC as kind of like teeth, or, you know, they're opening and closing. As they open and close, the distance between AC will obviously get smaller, larger, right? And the angle will get bigger or smaller based on how long AC is, and vice versa. So clearly, there is a relationship between the sides and angles in a triangle. More specifically, an angle and the side opposite that angle. There is a relationship. The bigger the angle, the bigger the side. The smaller the angle, the smaller the side. So that's trigonometry. We just deal with it mathematically. And basically, we use trigonometry to find out the length of a side if you know the angle, or to find the angle if you know the side. So that's kind of what trigonometry is more or less, roughly all about. Moving on. Ratio. So there are two words, trigonometry and ratio. A ratio is just a comparison between two numbers. For example, the ratio of boys to girls in Year 10 mathematics is 5 to 11. This means there are 5 boys, 11 girls, 5 to 11. For every 5 boys, there are 11 girls. And we can write it as a fraction as well. 5 to 11 is just 5 over 11. Okay, I'm sure you've come across this. Oh, I hope you have anyway. I'm pretty sure you would have. Obviously, this is my first year teaching you, but it's a straightforward concept. 5 to 11, you can write as a fraction 5 over 11. That's all it means. Trigonometric ratios. You don't need to know too much about ratios for this topic. You just need to know that you can write them as a fraction. Moving on. Now, sides of a triangle in relation to a specific angle. Now, what we're trying to say over here is, let's say we pick this angle. Let's say we're going to be talking about this angle. If we talk about this angle, then in relation to this angle, obviously there are 3 sides in a triangle, but in relation to this angle, we're going to describe each of the sides. So we're going to start off by saying, oh, that's a right angle. So the side opposite that right angle, we're going to call hypotenuse. Hypotenuse. And I'm going to label it as H. And then I'm going to say, and I'll do the next bit in red. I'm going to say, okay, the side opposite the angle I'm talking about, I'm going to call that opposite for O. Opposite O. And then finally, you have the side which is right next to theta. And when I say right next, obviously the hypotenuse is also right next to, but I'm not talking about the hypotenuse. I'm talking about the other side. The hypotenuse and the other side make up this angle theta. So I'm going to label that A for adjacent. Adjacent means right next to. So you have hypotenuse, adjacent, and opposite. I'll repeat the exercise on the right-hand side. So let's say we are talking about this angle, and I'm going to label that as such. And then I repeat what I did before. Okay, I say this is the right angle. Whoops. I say this is the right angle. So the side opposite the right angle is always the hypotenuse. Then I say, okay, this angle here, the side which is right next to this angle is adjacent. And I write A there, adjacent, A for adjacent. And then the angle, the side which is opposite that angle is going to be the opposite side. Okay, so sides of a triangle in relation to a specific angle. It's important that you get this right and you understand this, because as we move on, we're going to be using A, O, and H to refer to these sides. And it is important that you understand which one's opposite, which one's adjacent, which one's the hypotenuse. So pause the video if you're watching this on YouTube and watch it again and again, just so you understand before you move on. Moving on. What are trigonometric ratios? Okay, well, if you know the ratio of any two sides of a right angle triangle, you can find any angle on that triangle. So for example, and I'm going to give you an example, you obviously will not follow along at the moment, but you're going to learn how we do it. But for the time being, I'm just going to give you an example and then we'll verify it using a program. So let's say, for example, the hypotenuse is, I'm going to make up a number here. There were 11 girls in the class, and I believe there were 5 boys. So let's make a 5 and 11. And then I said to you, find this angle. And the idea is, because you know those two sides, you can find this angle. And this is going to look gibberish to you, and that's fine. But just follow along, and then hopefully you'll learn how to do this soon enough. I'm just going to show you that we can use maths to find an angle. And it's totally fine if you have no idea what's going on. Perfectly okay. Just follow along. And I'm telling you that's going to be around 27 degrees. So theta is around 27 degrees. So let's check. Let's go to a program and let's check. So we had what? 5 and 11. All right, cool story. Let's give it a go. We said that the hypotenuse was 11. So let's lock that in. And I said this was 5. Let's lock that in. And then I had to find the angle opposite 5. The angle opposite 5. So we are going to say, measure this, calculate the angle, and I want it in real numbers, and 27 degrees. So the program agrees with what I calculated. And the program obviously calculated it, and that's how you find the angle, 27 degrees. And I also got 27 degrees. So using simple maths in your calculator, you can find any angle on a right angle triangle as long as you have 2 of the sides. And that's really what we're learning. That's what we're trying to get at. And that's what you're going to be learning to do. So I know you don't know, that's fine, but that's our goal. If you have 2 sides, find an angle. Or if you have a side and an angle, you can find the missing side. So let's get started. There are 3 specific relationships and ratios that you'll be learning. So 3 things. And so if you have a right angle triangle and you have angle theta, then we say the sine of angle theta. And I know it's gibberish for now, but that's what we're learning, right? When I say sine of theta, then I mean the ratio of the opposite side. So what's opposite here? So this is going to be opposite. This is adjacent, and that's hypotenuse. Okay. Sine of theta is a ratio. It's the division of 2 sides of the triangle, and the division you have to understand it's opposite in relation to hypotenuse. Sine theta is equal to opposite over hypotenuse. So that ratio sine theta is equal to O, the opposite side, divided by the hypotenuse. So if this was 3 and that was 11, it would simply be 3 divided by 11. And that's it. And that's something you have to memorize. And we shorten this to help you remember it. We say SOH. And cos theta is another ratio. It's slightly different ratio. And this is adjacent over hypotenuse. And we shorten this as CAH. And finally, you have a third ratio, which is opposite side divided by the adjacent side. And we shorten this as TOA, SOHCAHTOA. So to memorize this, you have to remember SOHCAHTOA, SOHCAHTOA. And then when you go into an exam or you're getting tested or you just want to do trigonometry, you say SOHCAHTOA and you write down this, SOHCAHTOA, SOHCAHTOA. Everyone learns this. If you ask your elder siblings, maybe even your parents, I'm sure they'll remember SOHCAHTOA from their own high school days. But yeah, that's what SOHCAHTOA means. SOH is sine theta equals to opposite over hypotenuse. CAH, cos theta is equal to adjacent over hypotenuse. And tan is O over A. Tan theta is equal to O over A. And you can see I've color coded it over here. This is where it comes from. SOH is from sine OH, SOH. And then you have CAH and you have TOA. And these are simply the ratios of sides, the division of two different sides. Sine theta is the ratio opposite divided by the hypotenuse. Cos theta is adjacent divided by hypotenuse. And tan theta is opposite divided by the adjacent. And if you have this memorized, then that's pretty much all you need to solve for missing sides or a missing angle. We're not doing that today. Today, I just want you to become familiar with SOHCAHTOA, with opposite, adjacent, hypotenuse, and just setting out the ratios. So let's have a look at a worked example. Label the sides of the triangle O, A, and H, and write the ratios for that, and that. So first of all, we're dealing with this angle. So which one is opposite? The opposite side is M. So I'm going to write an O there. Which one's the hypotenuse? X is the hypotenuse. It's opposite right angle. I write H there. The left of one is adjacent. It's also right next to it. O, A, and H. And then it says, write the ratios for sine theta. Well, the ratio of sine theta is SOH. So I'm going to write SOHCAHTOA, SOHCAHTOA. And that'll help me remember. SOHCAHTOA. Sine theta is SOH. So I'm going to write sine theta is equal to, see, it's O and H. So I write O over H. And then to do cos theta, CAH is adjacent over hypotenuse. And tan theta was opposite over adjacent, so opposite over adjacent. Now, of course, over here, they have specific values. So I'm going to say sine theta is equal to, not opposite. What's opposite side? Opposite side is M. So I'm going to write M there. And what was the hypotenuse? Hypotenuse is X. So I'm going to write X here. So sine theta is M over X. Cos theta, adjacent. What's adjacent? N. So I write N here over the hypotenuse, which is X. And then tan theta, opposite is M, adjacent is N, and I'm done. Moving on. And now if you have specific numbers, it's no real different, right? Write down the ratio of cos theta. First thing I do, SOHCAHTOA. And a bit of tajweed never hurt, right? SOHCAHTOA. Pronounce that ha, to help you remember which one's the hypotenuse and so on. And then cos theta is CAH. Cos CAH, right? Adjacent. What is adjacent to this? This is adjacent, that's it, but that's obviously the hypotenuse because that's opposite the right angle. So this one must be adjacent, and that's the hypotenuse. And therefore, cos theta is equal to adjacent over hypotenuse. What's adjacent? 7. What's the hypotenuse? Square root of 74. And you're done. I know you should be rationalizing the denominator and so on. Don't worry about it. Just write down the ratio for the time being. And that's pretty much it. That's what we're doing today. You should be able to do the homework. Best of luck. As always, you can ask me for help on Slack if you need it. So I'm stopping the video here. And for the people who are present in the live Zoom session, if they have any questions, they can ask me. The rest of you at home, please get the homework done and ask me for help on Slack if needed. All right, best of luck.